So in this lesson, we are going to talk about parallelograms, how we can prove and apply the properties of parallelograms or solve problems using parallelograms. So go ahead and go through those first few warm-up questions if you haven't already, and check when you're ready. So the first one is the sum or total in a decagon. So 10 minus 2 times 180 is 1,440. Each is a specific one when it's a hexagon, that's 7. So 7 minus 2 times 180, and then that total divided by 7 to figure out what each of them are, and that's 128.6 degrees. Sum of the exterior is always 360, and then each exterior we're going to take the total and divide it by the number of sides, and a heptagon would be 7, so 360 divided by 7, oops, that should be a 6 up there, not a 7. For hexagon, heptagon is 7. So I'm going to fix that one. There we go. So that should be 120. So 6 is hexagon. Hepta is the 7. All right. So let's take a look at our parallelogram. So we have a four-sided figure called a quadrilateral. All four-sided figures are quadrilaterals, but some special properties give them that special name. So the symbol for a parallelogram is this, and you'll see that a lot throughout this chapter. So here are some properties of a parallelogram, kind of 5 main properties. And as we go through all these properties of different figures, on the last page of your notes, there is kind of a summary sheet. And so as we go through, like these 5 that we're about to go through, I strongly suggest you write these 5 and then your few others as you learn about those properties for each of them on there. So you can refer to them as we solve problems with all of these different figures and all of these different properties. So the first one is the definition, and that is that both pairs of opposite sides are parallel. That's why it's a parallelogram. So there's the opposite sides, and there's the other pair of opposite sides. The next property is that opposite sides are congruent. So they have those tick marks to represent that. Opposite angles are congruent. And then consecutive angles, or same side interior, right? The ones right next to each other, are supplementary. So x plus y would add up to 180, or this x plus y would add up to a 180. And then the diagonals, so from J to L, kind of cutting the figure in half this way or cutting the figure in half this way, bisect each other. So that means that it cuts them into 2 congruent parts. So let's go ahead with those properties kind of in mind, and I have written some reminders of those properties in the directions to assist you, depending upon which ones they're using. But if they don't have the labels in the picture, you want to go ahead and write those in, but we already have them put in our picture here for us. The first question is, what is CF? So up here in my directions, I have kind of some reminders of those properties. Opposite sides are congruent. Well, we're looking at sides, so opposite of that would be 74, so that means that CF would have to be 74. And we're millimeters. And then we are looking for angle, DEF. So angle, DEF is this angle up here. And we know diagonals bisect each other. Well, that's not a diagonal. Opposite angles are congruent. Oh, opposite angles. Well, this angle, DCF, is opposite of the angle we're looking for. And if it's 42, then that would mean this angle is 42 degrees as well. And now we're going to look at DF's length, which is this whole diagonal. Well, we know this part, 31, which it said diagonals bisect each other, which means that this part is going to be the same as this part. So it's 31. And that means a total of 31 plus 31, or 62 millimeters for DF. So we're using those 5 properties to help solve these problems for parallelograms. On this one, opposite angles, again, are congruent. So this angle and this angle are going to be the same. So we can go ahead and set 4x minus 9 equal to 3x plus 18 and solve. So I'm going to subtract my smaller variable. X minus 9 is equal to 18, and then add 9. So x is equal to 27, and it just wants us to find the value of x. So we are done. On this next one, opposite sides are congruent, and same side or consecutive angles are supplementary. I should say are. So opposite sides being congruent means that the top expression here is going to be equal to the bottom expression. So I'm going to go ahead and set 6a plus 10 equal to 8a minus 4 and solve. So 10 is equal to 2a minus 4, and we're going to add 4 to both sides. So 14 equals 2a, and divide by 2 to get a is 7. Now it wants us to find the length of YZ, which is this here. So we're going to take a of 7 and plug it back in. So 8 times 7 is 56, minus 4 is 52. So 52 is our answer there for YZ. And then the measure of angle Z, now we're inside here with our measures of angle Z. And that is going to be, again, same side interiors are supplementary. So they are going to add up to 180. So we need to add W and Z and set them equal to 180. So that's going to be 18b minus 11 plus 9b plus 2 equals 180. So I'm going to combine my b's together, and that's going to give me 27b. Combine my negative 11 and 2, since they're on the same side, to get negative 9. And then I'm going to add 9, just solving my two-step equation here. And then I'm going to divide 189 by 27. So b is equal to 7. And again, we want to plug it back in to find the measure of angle Z. So I'm going to take 9 times 7 plus 2, which is going to give me 68 plus 2, and that's going to be, 63 plus 2. It's been a long day. 65 degrees. On this next example, diagonals bisect each other, so that means that the left side is going to be equal to the right side. So this would be equal to this. 3w is going to equal w plus 8. And then we're going to solve. So 3w is equal to w plus 8. And 4z minus 9 is equal to 2z. Go ahead and put a line on my z so it doesn't look like a 2. So let's solve. We're going to subtract w from both sides to be left with 2w equals 8. Divide both sides by 2, and w is 4. So we're going to plug it back in to find jg. So 4 plus 8, and that is going to give me 12. Over here, I'm going to subtract my 4z, so I don't leave this side with nothing. And then I'm going to divide both sides by negative 2 to get 4.5. And I'm going to plug my 4.5 back in. I'm looking for the entire length of FH. Well, FH we know is 4z minus 9 plus 2z, which is 6z minus 9. So I'm going to plug in 4.5 for z. And I could just plug it into this one and then double it, if you can see that. And I'm going to get 18. So we've learned about the properties of parallelograms. Now we're going to be given the properties of a quadrilateral, and we're going to tell whether or not it is a parallelogram. So we're kind of using this side over here. We've kind of gone through these 5 with some examples. So now, if both sides are parallel, then it is a parallelogram. If both sides are congruent, kind of those opposite sides, then it's a parallelogram. If both those angles across from each other are congruent, then it's a parallelogram. We're going to show if the angles are supplementary, those consecutive angles. If both pairs are, then we can say it's a parallelogram. If the diagonals bisect each other, it's a parallelogram. And if we have one pair of opposite sides that are both congruent and parallel, we have a parallelogram. So keeping those 5, actually more than 5, we have kind of our 5 and then this additional one down here. So 6, keep those 6 in mind. So on this first one, I can see that we have here either supplementary or we have opposite sides being congruent. Or these adding up to that 180. So yes, and we can say consecutive sides supplementary or opposite sides or opposite angles congruent, kind of either one of those. This one, yes, opposite sides. Man, get my sides and angles confused here. Opposite angles are congruent because of our arc marks there. And since this is a quadrilateral, these must be the same if these are the same. And then here, this one is a no because remember it has to be congruent and parallel for just one pair of opposite sides. So no, parallel sides must be congruent. On this one, if we kind of think about what we were doing in the previous chapter, if we have angle, angle, side, these triangles are congruent, which means these are parallel, or these are congruent. Everything's congruent to itself, so these angles are even congruent. So we have opposite sides congruent and parallel. So triangles are congruent by angle, angle, side, or pretty much any reason there. And this would be a parallelogram, yes, because opposite sides parallel. And you can say they're congruent too. This one is a no because these are the ones that are opposite. And are those congruent if they have different tick marks? No. Opposite sides must be congruent. Oh, there we go. Yes, opposite sides are congruent. That's what we were looking for. All right, so these last 3 are done for you. Yes, diagonals bisect each other. No, we need to know that they are parallel and congruent. We just know that they're congruent. And then here, yes, 5 and 5 means they are congruent to each other, and those arrows mean they're parallel. So there's our one pair of opposite sides, parallel and congruent. All right, this last question here, it is graphed for you, and we want to figure out the slopes that are labeled here to see if those are congruent, or not congruent, but see if they are parallel so that we can prove that this is a parallelogram. So I'm going to go ahead and label this one would be -4, -1, so K. This one would be 7, 0, M. This one would be 4, 5, so L. And this one would have to be J. So KJ is this length here. I'm going to go down and straight across, kind of like what we did in the previous chapter where we were figuring out length, but we're just going to find slope. So we're just going to do rise over run. So I'm going to go down 1, 2, 3, 4, 5, and over 1, 2, 3. So my slope is -5 over 3, and then LM. I'm going to go with my slope here, and I'm going down 1, 2, 3, 4, 5, and over 3. So again, rise over run. So these are equal, so those are parallel. Now I'm going to check the other direction here, and I'm going to go up. 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8. And yes, we can reduce 6 over 8 and make it 3 over 4. And then same thing here, rise over run. 1, 2, 3, 4, 5, 6 for that rise, and run 1, 2, 3, 4, 5, 6, 7, 8. So 6 over 8 again, which is 3 over 4, they're equal. So we do have parallelogram because both pair of opposite sides are parallel.